Have you ever wondered why some of the smartest students, the ones who understand everything in class, somehow end up scoring lower on standardized tests? It doesn't seem to make any sense. You can solve complex problems, explain concepts better than your teacher, but somehow you still don't hit your potential on the SAT or ACT? Something's not right. This video isn't about blaming intelligence or saying tests are unfair. It's about understanding why the smartest people struggle sometimes and how to fix it. Smart students succeed in school because it rewards understanding, but standardized tests don't reward deep understanding. They reward pattern recognition, efficiency, and timing under pressure. So while a smart student might pause to think, what's the most accurate answer? The test literate student already knows. This question fits the pattern. The correct answer is probably C. It's not about being smarter. It's about being trained to think like the test wants you to. Let's dive into the issue. Smart students tend to rely on logic, and that's both their strength and their downfall. When something makes sense to them once, it feels like it's learned. That's called false mastery, the illusion that understanding equals retention. But according to the forgetting curve, even well-learned material fades fast without review. After just a few days, recall can drop by more than 50%. So by test day, the smart student remembers the idea, but not the details, like formulas, exceptions, or specific rules. They might say, I know this, but struggle to apply it quickly under pressure. That's the difference between knowing something in theory and performing it in practice. Let's break this down further. There are two dominant learning styles that come into play here: conceptual learning and pattern recognition. Conceptual learners focus on understanding the why. They love logic, reasoning, and seeing how things connect. Pattern recognizers focus on how problems appear. They see the type of question and immediately recall the method. Smart students often fall heavily into the first category, deep thinkers. But standardized tests are built for the second, quick recognizers. That's why a smart student who spends a lot of time carefully working through a complex math problem might end up with a lower score than someone who simply practiced recognizing the setup from past questions. The first student is trying to figure out everything from scratch, checking every step, while the second instantly recognizes the question type. It's not that one is smarter. The difference is that one has built pattern familiarity, and the other is still approaching each problem like it's brand new. Standardized tests reward the second approach. Another problem: timing. Logic takes time, and standardized tests punish you for thinking deeply. A student who is used to being rewarded for insight suddenly finds that insight slows them down. They read every option carefully, consider nuances, and double-check their reasoning. Meanwhile, another student instantly spots the familiar pattern. Oh, this is one of those questions. The difference isn't intelligence. It's test literacy. Test literacy is the ability to understand what the test wants, not what's objectively true. It's knowing that the SAT or ACT isn't asking for your opinion. It's asking for the answer that fits its internal logic. That's why the smart student often overthinks. They argue with the question instead of playing by the test's rules. Test literate students don't try to outsmart the test. They follow the pattern. They've seen how certain questions are worded and map previous questions onto the ones they are currently working through. Once you see those patterns, the test starts to feel predictable. So, how do we fix this? How do you go from a smart, frustrated student who understands everything but underperforms to a strategic, efficient test taker who can recall information instantly under pressure? It starts with changing the way you study, from passive learning to active recall and spaced repetition. Most students, especially smart ones, study in a passive way. They reread notes, rewatch lectures, or highlight things that already look familiar. That creates recognition, not retrieval. You feel like you know it because you recognize it on the page, but you blank when it comes to the details. Active recall flips that process. Instead of feeding your brain information, you force it to pull information out. Every time you retrieve something from memory, you strengthen the neural pathway that leads to it. It's like exercising a muscle. Let's take a look at an example. Let's say you're studying SAT math formulas. Instead of rereading the quadratic formula for the 10th time, you cover the page and ask yourself, can I write it down from memory? If you can, you've just reinforced it. The next time you do this, your recall will be faster and more automatic. That's why tools like flashcards and practice questions are very useful. They all rely on retrieval, the act of making your brain work to find the answer. And that skill directly translates to the testing situation. When the clock is running, you don't have time to remember where you saw it. You need instant recall. Active recall is the training grounds for that. Now, even if you use active recall, there's another problem. Your brain naturally forgets things over time. That's where spaced repetition comes in. Spaced repetition is the idea of reviewing information at increasing intervals. Let's say after 1 day, 3 days, 1 week, 2 weeks, and so on. This timing is based on the forgetting curve, which shows that memory fades quickly at first, then more slowly after each review. Every time you revisit a topic right before you're about to forget it, the memory gets stronger and lasts longer. Let's take a look at this in the context of standardized tests. Let's say that you've learned how to solve exponential growth problems on the ACT. If you review it just once, you'll likely forget the method by next month. But if you use spaced repetition, reviewing it today, again in 2 days, then in a week, and once more a month later, you'll still remember it clearly on test day. That's how high scorers seem to remember everything. They're not geniuses. They've just trained their memory system to resist decay. When you combine active recall with spaced repetition, you're building both accuracy and speed. Active recall ensures that what you know can be retrieved under pressure. Spaced repetition ensures that what you learned weeks ago is still accessible when it counts. The second part of transforming from a smart but inconsistent student into a strategic test taker is something called pattern-based review. Most students study by topic. They think, I'll review algebra today, or I'll go through 20 random math problems. That's fine for general understanding, but it doesn't train you for the specific logic that standardized tests use. Pattern-based review means you stop organizing practice by content and start organizing it by question type and structure. You're not just asking, what does this question test? You're asking, what kind of question is this and how is it built? It is a subtle but crucial difference. Because while two questions might test the same math topic, the way they appear, the phrasing, the setup, the traps, might be completely different. You're training your brain to recognize how these questions are built, not just how to solve them. Over time, your brain starts building what you could call a mental blueprint library, a catalog of familiar question types. Each blueprint tells you, I've seen this before, and here's how I solved it last time. The human brain is wired to find patterns. Every time you identify a reoccurring pattern, you're reducing the mental energy required to solve it. In cognitive psychology, this process is called chunking, grouping bits of information together so they can be recalled as one unit. For a beginner, each math problem is 10 new steps. For an expert, it's one familiar pattern, a single chunk their brain retrieves instantly. Standardized tests are designed to be predictable. Once you've internalized those blueprints, you're not solving a new problem. You're simply recognizing. Pattern-based review doesn't just improve speed, it lowers anxiety. Because you're no longer walking into the test thinking, I hope I've seen something like this before. You know you have. This confidence comes from repetition with structure. Your brain begins to expect the test's logic, anticipate traps, and approach each question like a familiar rhythm instead of a new puzzle.